lecture. My name is David Collard, and it's a pleasure to serve as the Dean of the College of Sciences on an interim basis for this academic year. The College lecture is jointly organized by the Georgia Tech Honors Program and the College of Sciences. Representing the leadership of the Honors Program this evening are Professor Roberta Barry, and Monica Halker is the Associate Director, herself a physicist. Thank you for the leadership, Roberta and Monica, of the Honors Program at Georgia Tech and for co-sponsoring and co-organizing the Calvert's lecture. The lecture series then is named after a previous dean, a mathematician, Les A. Calvertz. Dean Calvertz was in fact the dean not of the College of Sciences, but the Georgia Tech College for Science and Liberal Studies, or COSALS. He was the dean for 16 years until COSALS was reorganized in the late 1980s to form separate colleges of computing, liberal arts, and sciences. Through the Calvert's lectures, we seek to broaden the intellectual discourse on campus and in the broader community with speakers whose work has led them to stretch across disciplinary boundaries. A few years ago, the Calvert's lecture became a part of a regular series of lectures, of public lectures sponsored by the College of Sciences, the Frontiers in Sciences lectures. That series for a number of years has been organized now by Dr. Maureen Ruhi, the College of Sciences Director of Communications, and it was her idea about 2.5 years ago that the College of Sciences should celebrate the International Year of the Periodic Table in 2019. And the Dean's Leadership Council just ignored her. That's 2.5 years away, nothing to worry about. And she reminded us about 1.5 years ago, still a long way away. And then last fall, she really got serious about it, and so did we. And if you kept up with her Twitter feed or the College of Sciences Facebook page, you'll realize that we really are doing an awful lot to celebrate the 150th anniversary of Mendeley's organization of the elements that he knew into what today is a very recognizable pattern that we see when we see the periodic table on the wall of almost every science classroom in the country, it seems. Maureen's partner in organizing this year's Frontiers in Science lecture series, all about the International Year of the Periodic Table, is Associate Dean and Professor of Mathematics, Matt Baker. In addition to this lecture series, we're celebrating this year with a large number of public events all over campus. These relate not just to chemistry, but they relate to public policy and engineering and art and music and sport, and they make use of various media besides lectures and the artwork that students have presented and the music that students have presented. There's plenty of videos of personalities from around Georgia Tech, from undergraduates all the way through to President Peterson, talking about their favorite element. That sounds like a very Georgia Tech thing to do. And if you haven't subscribed to the College of Science podcast series, please seek us out at the College of Science's webpage to subscribe to that podcast series, which also has a lot of discussion of elements. Thank you, Maureen, for all you do in terms of communicating within College of Sciences, across campus, and to the outside world. Maureen's in the back. Wave, Maureen. Shadow in the back there. Dr. Baker will introduce tonight's Karlowitz lecturer.
Okay, thank you, David. Before I introduce the speaker for tonight, I wanted to tell you that there will be a t-shirt giveaway at the very end of this, after the question and answer session. And so stick around until that and hold on to your programs, because that's how you will know if you're one of the lucky winners or not. But tonight, as David said, we have a year-long series of Frontiers in Science talks about different aspects of the periodic table. And tonight, we are very fortunate to have a speaker who has written a book for the general public about this topic. And actually, I recently finished reading the book. It's great. So I think there will be a book signing afterward, and I encourage everybody to buy the book and read it and get it signed. But it's a wonderful book, and you'll hear some of the things that are in it. But our guest lecturer tonight, Sam Kean, is a New York Times best-selling author, and he's written many other books, including Caesar's Last Breath, The Dueling Neurosurgeons, The Disappearing Spoon, which is the one about the periodic table, and The Violinist's Thumb. His stories have appeared in the Best American Nature and Science Writing, in the New Yorker, the Atlantic Monthly, Slate, and his work has been featured on NPR's Radiolab, Science Friday, All Things Considered, and Fresh Air. His new book, The Bastard Brigade, is coming out in July. And so without further ado, I present to you Sam Kean.
Well, hello everyone. Thank you all for joining me this evening. You can hear me in the back okay? It's loud enough? Okay, great. So I had a bad go of things in about 3rd grade or so. I came down with strep throat something like a dozen times that year. And each time I did, I got to stay home from school, so it wasn't all bad as far as I was concerned. But, you know, I was feeling kind of achy, kind of flu-y. My mother would get a little fussy over me. She would come in. She would often try to take my temperature with one of those old-fashioned mercury thermometers, like you can see in the picture here. And I admit I was a little clumsy when I was a kid. I was also very prone to talking to myself. Still am somewhat, but back then especially, I was very prone to talking to myself. And, you know, not infrequently, my mother would come in. She would put the thermometer under my tongue, try to take my temperature. Then she would get distracted, the phone would ring, something would happen, she would leave the room, and I would be there by myself. I would start chatting away, doing whatever it did when I was a kid. And not infrequently, this would happen. The thermometer would fall onto our hardwood floor and it would break. And the mercury inside would go spilling all over the floor. But I always admit I was kind of secretly excited when that happened because I loved watching the mercury go scattering everywhere. It was like these little liquid ball bearings on our hardwood floor. And my mother was actually very cool about the whole thing. You know, she never panicked. She never made us evacuate the house like you'd probably have to nowadays. She actually would get down on her hands and knees with a toothpick, and she would start brushing the little spheres of mercury toward each other. And my favorite part was when she had 2 little spheres of mercury right next to each other. And she would give them one final nudge, and then they would jump together into this slightly larger sphere that was perfectly seamless. And I just thought it was the most amazing substance I had ever seen in my life. I mean, it was a metal, it was dense like a metal, but it was very shiny, very attractive, and it was also a liquid. It flowed around like that. And, you know, I managed to accidentally break enough thermometers over the years where we had quite a nice collection of mercury. My mother kept it in a little pill jar on a knick-knack shelf in our house, and if we'd been good that day, she would get it down, whisk it around, let us play with it a little bit. I had a lot of really nice memories of this one element, mercury. So when we got introduced to the periodic table in school for the very first time, the first thing I tried to do was find mercury on the table. I looked top to bottom, looked all over, and I couldn't find it. I just did not see mercury on the periodic table. Now, of course, mercury is on the periodic table, but the symbol for mercury is actually Hg. Neither of those letters are in the word mercury, and I thought, well, boy, that's kind of stupid. Why would that be the symbol if those letters aren't in the word? So I looked into it a little more, maybe got some help from my teacher or something, and found out that, oh, okay, this symbol actually comes from some Greek and Latin words, so very, very old, the root of this symbol. And I thought, well, that's really interesting. I didn't know they knew about this element thousands of years ago in classic Athens and classic Rome. And it turns out that not only did they know about this element, but they incorporated it into different areas of their life. For instance, there was a god that they associated with this element, with mercury. Also a planet that they associated with it. And the more I looked into it, the more I realized that, wow, mercury really does have this rich, long, interesting history. Alchemists, for instance, were obsessed with mercury. They were always using it in different kinds of experiments. When they were colonizing the New World, they sent galleons that had big, big vats of mercury over to help out with gold and silver mining in the New World. There was even kind of an unusual connection to American history, to the exploration of North America. Now, I'm from the Midwest. I'm from South Dakota. So we always had a very, very long Lewis and Clark section in our local history class. But there was one story about Lewis and Clark and mercury that did not come up in class for reasons that will probably become obvious as I go on with the story here. So this story actually gets started with this man right here, Dr. Benjamin Rush. Considered one of the founding fathers of the United States. He signed the Declaration of Independence, that whole thing. He was probably best known during his lifetime, though, for staying behind during a yellow fever epidemic in Philadelphia in the 1790s. He was a physician. Most other doctors basically just abandoned their patients, fled the city. He very bravely stayed behind, and he treated a lot of people who wouldn't have gotten treatment otherwise. So very brave of him to do that. Unfortunately, his pet treatment for pretty much any ailment you had was this mercury chloride sludge he would feed them, often until their hair started falling out, their teeth would get loose and fall out, they'd start drooling from the side of their mouths. The idea in medicine at the time was that you kind of wanted to fight fire with fire. So if you had something ugly like yellow fever that was giving you an ugly reaction, you had to fight it with something that would produce an equally ugly reaction. And mercury was at the top of that list. I mean, mercury definitely provoked a strong reaction in people. Now, that's not how we think about medicine nowadays, of course, but that was kind of the leading theory back then, one of the theories. Anyway, Dr. Rush thought that this treatment was fantastic, started mass producing them, mass producing patent pills. He made them, they were about 4 times the size of an aspirin, so very, very large pills. Called them Dr. Rush's bilious pills. And he packed 600 of these pills with Lewis and Clark when they went wandering through the wilderness. And there's really no delicate way to put it, but these pills were extremely powerful laxatives. They called them thunderclappers. And the idea was that if Lewis and Clark ate something that they probably shouldn't have, or they drank some questionable water, they could take one of these pills and it would basically flush them out. It would get rid of everything in their system. Mercury is a poison. Your body does not want it inside you, and it will move through your digestive tract fairly quickly. And we know that this worked for Lewis and Clark, and we know that apparently they took advantage of this remedy, because it's had a bit of an unusual side benefit for historians and archaeologists today. Because they can actually now pinpoint a few places where they know Lewis and Clark must have stayed because the level of mercury in the soil is just too high for it to have been natural. So from this one element then, from just mercury, I learned some unusual American history. But I also learned about etymology, word origins. I learned about alchemy. I learned about mythology, planetary science, poison forensics, even a little bit of chemistry. And that's really how I got interested and excited about science for the first time, was hearing these stories about things like elements on the periodic table. And what I was really trying to do with this book, The Disappearing Spoon, was to gather all of these great stories about elements into one place. Because the premise of the book is to find a funny or spooky or weird story about every single element on the table. And I did manage to cram all 118 of the elements in there. Some only make a cameo, but each one does have its role to play. And there were really 2 motivations for writing the book, besides just getting all of these stories together. And one of them was that, I don't know what your experience has been in chemistry classes, or was in chemistry classes, but I was always a little frustrated that we seemed to talk about the same few elements over and over and over again. It was always nitrogen and oxygen and carbon, but there were so many other elements on the table, just huge swaths of the table that we never, ever talked about. They never came up in class. And I wanted to know, well, what are the stories of all of those other elements? I wanted to give them a bit of a personality, make them come alive a little bit. And the book gave me the opportunity to do that. But the other big motivation I had was that I knew there were some really great stories out there about elements that we all think we know really well. But if you dig a little bit deeper, scratch a little bit below the surface, you can find out that they do really have a rich, interesting backstory to them. And probably the best example of that, of an element with a hidden, unusual backstory, is the element aluminum. Now, we all know aluminum today. It's in pop cans and aluminum foil. In some ways, it's kind of a throwaway element. It's one we don't think about a whole lot, probably on a day-to-day basis, even though it's a very common metal. But believe it or not, for a long time during the 1800s, aluminum was actually the most precious metal on Earth. It was worth far more than silver was, worth far more even than gold was. And the reason why is that even though aluminum is very common, it's the most common metal in the Earth's crust, even though it's very common, it's always tightly bonded to another element in nature, usually to oxygen. So it's not like you can go out and find a mother lode of pure aluminum. It's always in a mineral form of some variety. So when chemists in the early 1800s started to get the first pure samples of aluminum, it was considered kind of a miraculous metal because it was very light, but also very strong, very attractive, had a nice sheen to it. It basically had everything, every attribute you would want in a metal. And because it was so hard to produce and so expensive to produce, it became something of a status symbol for kings and emperors to get their hands on samples of aluminum. So right here, you are looking at an aluminum centerpiece that was created for one of the emperors of France. And you'll notice that's aluminum on top, and then that's gold beneath it. Because aluminum was the more impressive metal, so obviously you would want to showcase that by putting it on top. Another emperor of France also had this prized set of aluminum cutlery that he reserved for his most favored guests at banquets. And the lesser nobility were actually reduced to eating with gold knives and forks. It was considered very embarrassing to be seen eating with the gold knives and forks when there was aluminum silverware available. And even the United States got into this game a little bit. Does anyone recognize what this is right here? What's that? It's not Empire State. I thought I heard it. It is the Washington Monument in Washington, D.C. And it's kind of a close-up of it, obviously, but when the US government was putting the Washington Monument up in the 1880s, they decided they were going to put a 6-inch pyramid of aluminum on the very tippity top of the Washington Monument. And they did that for a couple of reasons. First of all, if you've ever seen a picture of the National Mall or maybe been down and visited there, you know that the Washington Monument is standing there all by itself and there's nothing else around it. So they knew lightning was going to strike it at some point, and they wanted a metal up there on the top to act as a lightning rod to help get the electricity safely to the ground. But the reason they chose aluminum, out of all the other metals they could have chosen, was that, frankly, the US government was bragging a little bit. They were saying, we are such an up-and-coming industrial power that we can afford to put aluminum on our public monuments. Isn't that impressive? And there were a lot of other countries around the world who were very impressed with this. For a while, because not long after that, the aluminum market basically crashed completely. What happened was a couple of chemists, a couple of European chemists and one American chemist, they figured out how to mass produce aluminum, produce it on an industrial scale for the very first time. And the American chemist became very, very famous. A young man named Charles Hall. He worked on it as his undergraduate research project at Oberlin College in Ohio. And then he figured it out, he had a big breakthrough about a year after graduating. So he was only 23 years old when he came up with this breakthrough. They called him the Aluminum Boy Wonder. And probably no one has ever made more money more quickly on the periodic table than Charles Hall did. Because when Charles Hall founded his company, Aluminum Company of America, known as Alcoa, when he founded Alcoa, he was shipping out about 50 pounds or so of aluminum each day, and that was plenty to meet demand countrywide. 20 years later, he was shipping out almost 90,000 pounds of aluminum every single day, and he could barely keep up with orders. He died a very, very wealthy man based just on his knowledge of what was then an obscure element on the periodic table. And I like this story because it goes to show how the fortunes of the elements really do change over time. I mean, it makes me wonder, what elements do we think of nowadays that are so important that 100 years from now, maybe people will snicker at us a little bit, that we took these elements so seriously. Or conversely, what elements nowadays that we not really pay attention to that in the future could be worth a lot of money. The fortunes really do rise and fall over time. And if I'd had to give this title sort of an alternative talk or an alternative title, something like that, I might have called it something like, Can the Periodic Table Tell a Story? Not, Can the Periodic Table Tell a Story? But more like, boy, can the periodic table tell a story? No question mark. Because to me, it always seemed obvious that the periodic table could. And in fact, I think the periodic table is probably the richest source of stories out there in science because it intersects with so many different areas of human life. People eat and breathe the periodic table. They bet and lose huge sums of money on which elements are going to rise and fall in fortune over time. Philosophers use it to probe the meaning of science. It poisons people. It spawns wars. One chapter in the book, I talk about some very recent wars in the 1990s and 2000s that were actually driven by certain elements on the periodic table that we probably all have in our cell phones right now. They're really driving these big, big conflicts. The worst conflict in the world with the most deaths since World War II was driven by one of these elements on the periodic table. So this isn't all ancient history. It's things going on nowadays in the modern world. But the story I wanted to talk about now wasn't about an ongoing conflict. It wasn't about a hot war. It was about the Cold War that sort of descended on U.S. society in Western Europe and kind of the world, in fact, after World War II. And you wouldn't think of something like the periodic table being wrapped up in international politics and international intrigue and all these kind of things. But it actually was. The periodic table so permeated our entire society that not even something like the periodic table could escape it. And in fact, the periodic table became something of a proxy battle for the Cold War in kind of a twisted way. So this story gets started with a few chemists at the University of California at Berkeley, especially the person in the middle there, a very famous chemist named Glenn Seaborg. So remember that name, Glenn Seaborg. But to understand this story, we're going to have to back up a little bit and go maybe to the very early 1900s. So very early 1900s, that was a time when the best science in the world was going on in Europe. Europe was definitely where all the top scientists were. If you were, an American student then, you had to go to Europe, do your PhD there. That was really where all the great science was. But, there were a lot of American scientists who were working hard. They were kind of scrappy, trying to make their name, trying to impress the Europeans. And especially, they were trying to impress them with really basic science, things like maybe finding new elements on the periodic table. So these scientists were constantly going out looking for new elements, trying to find evidence of new elements. So how many people in the room today have either lived in or maybe from Illinois? A few? Okay. How about Virginia? A few more? Okay. How about Alabama? A few? Okay. Well, believe it or not, all three of those states could have had an element after them. There could have been an alabamine, there could have been an alinium, and there could have, would have, should have been a virginium. What happened was U.S. scientists, they went out, found some new mineral or something, broke it down, thought they'd isolated a new element, ran some tests on it, confirmed it, they published a paper on it, sent the paper out. The paper would eventually make its way over to European scientists. But they would get the paper, they'd kind of flip through it, and they would say, well, no. we don't think you actually discovered this element. Maybe there was some contamination, or maybe you're just kind of misinterpreting your results, but we just can't count this as an element. We're sorry about that. And then these European scientists, they would turn around, they would discover the element, and they would name it something like francium. So they got to put their names on the periodic table, but they wouldn't let US scientists get credit for them and put their names of states on the periodic table. Eventually, though, the sort of dominance of Europe in science waned a little bit, and especially by the 1930s, 1940s, US science really came into its own. And there was a group at the University of California at Berkeley, led by Glenn Seaborg, among other people, that started to find new elements on the periodic table. And this was a big deal because there really hadn't been much good work on that in the US until that point. And chemists associated with California, Berkeley, discovered the first artificial element beyond uranium, which is neptunium, element 93. They also discovered plutonium, element 94. Also discovered element 95, 96, 97, 98, 99, 100, 101, just on and on and on. Box after box after box on the periodic table, these chemists at Berkeley discovered. And there was a lot of pride that this work was going on in the United States, because a lot of it, again, was taking place during the very early Cold War. We had a big rivalry with the Soviet Union. This was the era of Sputnik, a lot of fears that the Soviets were advancing beyond us technologically. And we wanted to show people that we had the best scientists in the world. And in this one realm of finding new elements on the periodic table, this was definitely true. We had the best scientists in the world. But there were scientists in other countries who were watching the Berkeley team, studying their methods, rerunning their experiments, and getting pretty good on their own, including a team in the Soviet Union. Unfortunately for them, though, this team in the Soviet Union had a bit of an obstacle that scientists in the rest of the world did not face. And that obstacle was this man right here, Josef Stalin. Now, Stalin considered himself an expert in pretty much every single scientific subject that existed. He thought he was especially sharp when it came to kind of the human sciences, things like economics, psychology, maybe a little biology, stuff like that. But he thought he was pretty good when it came to the more physical sciences too, things like chemistry and physics. Except there were a couple of parts of modern physical science that he just didn't like. Specifically, he didn't like quantum mechanics, and he didn't like relativity. It seemed like they were kind of spooky and kind of counterintuitive, and there was always a lot of math involved, and he just wasn't really into that. And so he decided that the best way to handle his discomfort about quantum mechanics and relativity was to make them illegal in the Soviet Union. And if you wanted to practice them or to use them, that was fine, but you were going to go to the gulag for it, and you'd probably die there. And so Stalin was getting ready to implement this, going to have a big purge of all of these scientists who wouldn't give up quantum mechanics and relativity, until a very, very brave advisor sort of raised his hand in a meeting one day, and he said, well, Premier Stalin, that is a fantastic idea. But it might hurt our nuclear weapon program, just a little bit if all the scientists are dead. And Stalin thought about this for a moment, and he decided, this guy was probably right. It probably wasn't going to be the best thing for their atomic weapons program. And so he made a very magnanimous pronouncement. He said, "Leave the scientists in peace. We can always shoot them later." And these were the kind of pressures that scientists in the Soviet Union were facing. And working on things like elements on the periodic table, they were not immune to these pressures because, again, they were working with elements like plutonium, which is very important for atomic weapons, so they had to face a lot of these pressures. Now, thankfully for everyone, I think Joseph Stalin died in the mid-1950s. Things thawed a little bit, at least in the Soviet Union. And these scientists who were working on creating new elements in the Soviet Union got their own institute, started really studying the Berkeley team's methods very intensely, started redoing some of the experiments, doing some of their own experiments. And then suddenly, in the early 1960s, they beat the Berkeley team to an element. They discovered an element first. And when the Berkeley team heard about this, they were not very happy. They were used to being the world leaders in this field, and they did not want to get scooped by anyone, much less a team from the Soviet Union. So the Soviets published a paper about this. The Berkeley team got a hold of the paper, and started flipping through it, and they said, well, no, we really don't think you discovered this element. Maybe there was some contamination, or maybe you're misinterpreting your results. So basically, they did to the Soviet team what everyone had been doing to the American team for all those years. But the Soviet team ignored them, kept going. They discovered another new element. So they were 2 up on the Berkeley team now. Well, the Berkeley team wasn't going to stand for this, so they got going. They revved up their machines. They started producing these elements. They published a paper about it, sent it out. The Soviet team got a hold of the paper. They started flipping through it, and they said, well, no, we don't think you discovered this element. And it kept going back and forth like this. One team would say they discovered an element, publish a paper, the other team would get it, and they say, no, you didn't, we discovered this element. Then they would turn around and they say, no, you didn't, we discovered this element. And it kept going back and forth like this, back and forth, back and forth. And what really, I should say that, so this battle over who was going to get the rights for these elements lasted all through the 1960s. It lasted all through the 1970s, lasted all through the 1980s. Then the Soviet Union collapsed. The Cold War was over finally. But they were still fighting about who was going to get credit for these elements well into the 1990s. This battle outlasted even the Cold War itself. And what they were really fighting about, what really got their hackles up, was the debate and the dispute over the names of the elements. It was the names of the elements that were the really important thing. Because if you're a scientist and you discover like some new species of salamander, or you find some new crater on Mars or something, you have the right to name that thing. It's kind of a nice perk of being a scientist, is you get to name this thing that you've discovered. But I mean, let's be real. Your little salamander or whatever isn't going to be hanging up in every single science classroom. From now until the end of civilization, the way the periodic table is. The periodic table is the most precious real estate in all of science. And these chemists were well aware of that. That's why they were fighting so hard over who would get to name these elements and honor the people and places they wanted to name. And the Americans had done something that really made the rest of the world mad. It was considered a very boorish thing to do. And that is, they were trying to name an element after Glenn Seaborg, who was still living at the time. There was kind of this informal rule in place that naming elements was kind of like postage stamps. You could name an element after someone, but you were supposed to wait till they were dead for a few years. You weren't supposed to do it while they were alive, kind of a gauche thing to do. But the Americans said, no, he's the most important periodic table scientist of this century. We want to name an element after him. So eventually, because the Americans and the Soviets couldn't figure this out, they turned everything over to this group of 9 international chemists, a tribunal, and they said, you guys figure this out. So they started visiting the labs, they went and talked to everyone, and eventually these 9 chemists, the tribunal, came to the American team, and they said, we're very sorry, but we just can't let you name an element after a living person. It's just not how things are done. And the Americans said, okay, well, thank you very much for your input. We no longer recognize your authority, and we're going to keep using the names that we want to use in the United States. And the tribunal was a bit taken aback by this, as you can imagine, and they said, well, you can't do that. And they said, we just did do that. And so the tribunal, they kind of huddled up again, and they started whispering. They said, they can't do, how did they do it? What are we going to do? So they went back to the American team, and they said, well, okay, you win. And as you see in the picture here, that is a very aged Glenn Seaborg, and he's kind of pointing toward element 106, which is now and forever will be known as Seaborgium. And I love this picture for a couple of reasons. One, he was the first person to ever get to see, during his lifetime, his own name on the periodic table. So it's kind of a historic moment in that sense. And there's actually a bit of a chemistry joke about the whole thing in that, so there was Seaborgium named after him. There was also berkelium named after Berkeley. There was californium named after California. There was americium named after United States of America, after America. So the joke was that now you could actually address a letter to Glenn Seaborg just using elements on the periodic table. So people thought that was kind of cool. And the other reason, though, I like this picture is that, frankly, it's a bit of a fraud in that Glenn Seaborg, he looks like just this nice, sweet kind of grandpa guy, just, this, oh, shucks, I got my name on the periodic table. But it really doesn't show how much anger and rancor and how bitter and angry things got. So if you know the backstory, I think this picture is a little bit misleading. But that's probably why it's one of my favorite pictures overall in the book. So in addition to these kind of big stories about wars and Cold Wars and things like that, another thing I wanted to do in the book was I wanted to highlight a lot of the personalities, a lot of the people, the scientists, the individuals who went into making the periodic table what it is. People like Marie Curie, vital for understanding radioactivity and a lot of the elements toward the bottom of the periodic table. Also Ernest Rutherford, Niels Bohr, Albert Einstein, these really big names, all of them had roles to play in shaping the modern periodic table. But there were other scientists, or other people too, who were very interested and invested in the periodic table, but weren't necessarily scientists that I never expected to see connected with the periodic table. People like Mark Twain, for instance. We all know him from his sort of laddish riverboat novels, but during the end of his lifetime, he actually got very interested in periodic table science. And in fact, wrote a short story called Sold to Satan about two of the elements that Marie Curie discovered, about radium and polonium. And it's really unusual to think, it's almost impossible to imagine the most famous short story writer in the country nowadays writing a short story about elements on the periodic table, of all things. But Mark Twain was very plugged into the chemistry community. So I thought that was a kind of a cool little anecdote about the history of the periodic table. But the next story I wanted to talk about actually does involve a scientist, but someone who's not very well known. And I think it's a bit of a shame that he's not better known, both because of the great scientific work he did, and also because he did have kind of a big, outsized, colorful personality. And that scientist is this man right here, Georgy Hevesy. So in 1910, Georgy Hevesy arrived in England, in Manchester, England, to work with the famous scientist Ernest Rutherford. And Rutherford immediately assigned him what he knew was going to be a pretty difficult task. He had a block of lead, and he said, okay, there's a block of lead here. It's slightly radioactive. So what I want you to do is I want you to separate out all of the radioactive atoms inside this lead. So I want all the radioactive atoms on one side. I want all the regular lead atoms on the other side. So get to it. Well, it turned out not to be just a difficult problem, but an impossible problem with the tools that they had at the time. Because the radioactive atoms inside the lead, they all assumed it was a different type of element. Turned out it was just a radioactive isotope of lead. They didn't know about isotopes back then. They had no idea any of that stuff. So with the tools Hevesy had at the time and the knowledge he had, this was an impossible project. There was no way he could do this. And unfortunately for him, he wasted 2 full years of his life tediously trying to tease all these little radioactive atoms out before he finally just gave up on the project. And even more unfortunately for him, he was also facing some domestic frustrations at the time. So he was from Hungary, and he was a bit of an aristocrat there. So he was used to very good, very savory, very spicy food. And to put it mildly, this was not the type of food he was getting at his English boarding house. The food was pretty bad, pretty mushy, pretty gross. He did not like it. And even worse than that, he started noticing patterns in the meals that his landlady was serving. It's sort of like in high school when you would have, hamburgers one day and then like chili the next day. And I wonder how fresh the meat in the chili is. He realized the landlady was recycling her meat day by day. And he kind of confronted her about this. He said, we're paying for fresh meat every day. Are you buying fresh meat? She said, oh yes, very, very fresh meat. So didn't have any proof. He kind of had to back down from his accusation. Now, miraculously, he'd actually achieved a breakthrough in lab around this time as well. Now, he still couldn't tease out those radioactive atoms, but he realized that actually, if you think about it, he could maybe kind of flip that to his advantage. Because he started thinking about the possibility of what if I took some of these lead atoms and injected them into a living creature? So the body would metabolize them, they would start to move around inside the body. But as they moved around, there'd be radioactive atoms mixed in. And as they moved around, they would emit little beacons of radioactivity as they moved throughout the body. Now, they did have X-rays in this era, so they could look at bones, they could look at hard material. But they had no way to look at soft tissue, no way to look inside veins, no way to look inside organs. And Hevesy realized that, wow, if they're metabolizing them, if they're moving throughout their liver and their heart and their bloodstreams, we could actually look inside living people's veins and organs. This would be a huge, huge breakthrough. Now, he realized, of course, you can't just do this right away. You have to test it on different things. Wanted to test it, this radioactive lead, on different tissues, kind of see how it worked. But before he tested this on the tissue of a living being, he decided to test it on the tissue of a non-living being. And it was a test with, frankly, a bit of an ulterior motive. Because he went home to dinner one night, and when his landlady's back was turned, he pulled out from his pocket a little vial of radioactive powdered lead. And after he'd finished up for that night, he took the little vial and he sprinkled a little bit of this radioactive lead on the meat that was left over on his plate. Slipped it back in his pocket. Then the landlady took the meat, took it back in the kitchen, and he waited a little bit. Came home the next day for dinner with a newfangled radiation detector that his lab buddy, Hans Geiger, had made. And he asked his landlady, so are we having fresh meat tonight? And she said, oh, yes, very fresh meat tonight. And he said, really? Took the radioactive Geiger detector, started waving it over his plate, click, 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 click. It went furious. It was off the charts. And he confronted her with the evidence. Now, unfortunately for him, Hevesy was a bit of a scientific romantic, and he laid it on a little thick, explaining all the mysteries of radioactivity. And in fact, the landlady was so charmed to be caught so cleverly with the latest tools of science that she didn't even get mad at Hevesy. There's no record, unfortunately, though, of whether she actually altered her menu for him, so I'm a little doubtful about that. But to skip ahead a few years in Hevesy's life, after this point, he started moving around to different labs throughout Europe and kept working on this idea of chemical tracers, basically putting radioactive ions in the body, or radioactive atoms in the body, having them move around. It was the start of what we now know as nuclear medicine. All started with Hevesy. So he was doing this work, and he kept getting nominated for the Nobel Prize for it, but kept losing out for various reasons. Unfortunately for him, though, Hevesy had some bigger problems going on than just a lack of a Nobel Prize. He was mostly working in places like Austria and Germany in the 1930s. There were some bigger things going on in Austria and especially Germany in the 1930s. Namely, Adolf Hitler was coming to power, consolidating power, and Hevesy especially, who was half Jewish, was in big trouble. He kept having to move, basically, to stay one step ahead of Hitler. He finally ended up at the Niels Bohr Institute in Copenhagen, and things seemed to be safe there until suddenly Germany invaded Copenhagen, invaded Denmark, took over the whole city. He was trapped there. So this was a problem for him. But they had an even more immediate problem in that at the Niels Bohr Institute, they actually had a couple of gold Nobel Prize medals that two scientists in Germany had sent to them for safekeeping. One of these scientists back in Germany was Jewish himself, and another one was a Jewish sympathizer and defender. So they'd sent them to Copenhagen because they would get looted if they were in Germany. Unfortunately, Hitler had made exporting gold out of Germany a capital crime. So if they found the metals, they were basically going to execute these scientists, especially because when you win a Nobel Prize, they etch your name right into the prize. So as soon as they got these medals, they're going to turn them around, see the names, these people were going to die. So they realized they had to do something to conceal or hide these metals in some way. And the first suggestion was, well, why don't we bury them in the backyard? But Niels Bohr thought that that was maybe a little obvious. Like they have this nice plush lawn back there, and then there are two little circles of dirt sitting in the middle of the lawn. Like they're going to know something's buried there. So as Hevesy later recalled, while the invading forces marched in the streets of Copenhagen, I was busy dissolving the metals in liquid. And to do this, he used aqua regia, which is a mix of nitric and hydrochloric acids. It was well known to the alchemists, for instance, because it's one of the few things that can actually dissolve gold. And the Nazis busted into Bohr's Institute. They ransacked it, took everything they could, but they didn't know what aqua regia was. They left it untouched on the shelf. Eventually, Hevesy was forced to flee Stockholm in 1943, but he left the beakers there. And when he came back to the laboratory after VE Day, they were still sitting there undisturbed on the shelf. So he blew off the dust, precipitated out the gold, sent it back to the Swedish Academy, and they recast the medals for both of the scientists who'd sent them into Germany. So they got their medals back. And Hevesy's only complaint about the whole ordeal was that he missed a whole day of lab work while he was fleeing Copenhagen. So a true scientist there. That was his big concern. And I am happy to report that Hevesy did eventually win a Nobel Prize of his own for this work on chemical tracers very shortly after that. So the good guys ended up winning in this case, and the stunt with his landlady ended up paying off for him with a Nobel Prize. So I thought I would wrap up briefly with a bit of reflection about the periodic table itself. So here is the periodic table, or a periodic table. And one question people often have is they want to know, are there new elements out there waiting to be discovered? Are scientists going to find new elements? And the answer is kind of. Because scientists aren't going out and kind of getting their fingernails dirty and finding new elements in nature nowadays, as much as they're creating them in a lab. These are artificial elements that they're making with big experimental apparatus. And the newest element, the latest brand new element to be added to the periodic table is down there in the corner, element 117, known as tennessine, named after Tennessee. And it was really a special moment in periodic table history. So imagine if tennessine wasn't there. Imagine there was a gap there for tennessine. It'd be kind of frustrating. It'd be like a nice row of teeth with one missing. Like you really just want to fill that last spot in. So when we finally got to plug tennessine in there, it completed that bottom row of the periodic table, squared things off, really made it look nice. And it was a special moment because we've never had a full, complete periodic table like this with all of the rows complete like that. Elements over history were discovered kind of haphazardly, and they would plop them wherever. There were always holes there until now. We finally have completed a row. And it's even more special because there are scientists out there already working on making new elements. Maybe the next one will be element 119 or maybe 120. And as you can see, when they discover the new element, it's going to have to go into a new row. But the problem is these new elements they're making nowadays are incredibly hard to make. They're very expensive to make, millions and millions of dollars. It might take a decade of work to make them. And at the end of it, they might have 5 atoms of it, 6 atoms of it, and then they just disintegrate almost immediately. So they make very minuscule amounts, and then they disappear right away in just a second or maybe even a millisecond or two. So it's kind of an open question if these elements are so fragile of how many more elements we're going to be able to get. We could just get to a point where it's impossible with modern technology to make new elements, and that will be the final element that we can put on the periodic table. And so people want to know at that point, well, is the periodic table kaput? Is it just a fossil at that point? And the answer is, I hope not. I think there's more to do, more things we can do with the periodic table to kind of bring out new qualities of it. One of the real delights of writing the book was realizing that, we're all sort of used to this standard periodic table, kind of a castle with turrets, little landing strip or whatever on the bottom there. But there really are a lot of different arrangements of elements out there. People have been really creative about how they have reimagined the periodic table. And I thought I would share briefly a few of them with you. So there are periodic tables that look like galaxies with hydrogen in the center and all of the other elements spiraling around it. There are periodic tables that look a little bit like board games to me. Periodic tables that are in 3D or that kind of have a double helix motif kind of thing going on. There are periodic tables mapped topologically onto elephants and taxi cabs and buses and all sorts of different things. This is at the American Chemical Society headquarters in Washington, D.C. They have a periodic table elephant there. There's actually a periodic table Rubik's Cube where it's shaped like this, and you can twist it and turn it and put the elements in all sorts of different arrangements. Not really sure what good that is to do it, but there is a man out there who has a patent, a US patent, on a periodic table Rubik's Cube. And my favorite arrangement of elements, though, actually involved a woman who came up to me after a talk much like this, and she confessed she was kind of a periodic table nut, and that not long before that, she'd gone to one of those photo booths that you see at like a fair or an arcade. You know, you hop in and out, and you make a different funny face in each picture, something like that. So this woman had gone into and out of this booth something like 30 different times, gotten roughly 120 pictures of herself, making different faces, brought them home, cut each one of them out, and then arranged it into a periodic table of herself. And then she took that and she hung it on her fridge so that she could see herself as the periodic table every single morning when she got up for breakfast. And while she was telling me this story, I just thought, wow, just God bless you for doing something so ridiculous, like making yourself into the periodic table. I just thought it was the weirdest thing I'd ever heard. But the more I thought about it, the more I realized that, that this is kind of fitting in some way. Because we're all used to one side of the periodic table, the scientific side. It's something that's literally universal. It's the basis of all of chemistry, a lot of biology, a lot of physics too. It's one of the iconic things in all of science. But it's also a treasure trove. It's a reflection of all of our passions and all of our obsessions as human beings. And even if we don't go as far as she did in making the periodic table her own, it is our thing. It's a human thing above all. And I am constantly amazed at all that we have been able to fit in there. So again, thank you all for joining me. I appreciate it.
Thank you so much for the great talk, Sam. We do have time for some questions. If there are, Marty, you want to help? Raise your hand if you have questions.
Unless we need a spoiler alert, why is it the disappearing spoon?
Why is it called the disappearing spoon? Okay, so I'm going to actually go over to, so element, so see where B is there on the top, kind of the corner there, that's boron, and then beneath that's aluminum, and then beneath that's gallium. So it's a story, it's right there, it's gallium. So it's a story about gallium, and you see gallium does sit below aluminum. So because they sit right next to each other on the table, they're very similar properties. And if you had a chunk of one and a chunk of the other sitting in front of you, it'd basically be impossible to tell them apart. Except gallium does have one unusual property, in that it melts at about 85, 86 degrees Fahrenheit. So you take some in your hand on a warm day, you start to squeeze it, it's going to melt. The metal is going to start to run between your fingers. So the title, The Disappearing Spoon, comes in because it's sort of frankly, kind of a classy nerd science prank to make a spoon out of gallium metal. Then you serve it to somebody with hot coffee or tea or something like that. And they, of course, thinking, they're just getting a regular aluminum spoon. They start to stir the coffee with it, and then it disappears on them. So that's where the title comes from.
Okay, so one mystery of the universe answered. Next.
How toxic is the melted gallium?
That's the next follow-up question. So gallium is not acutely toxic. It would not do you, it would probably not poison you if you swallowed it, but it's a big slug of metal in your stomach. Not going to be comfortable going through you. So it's not a good idea to drink it, but it's not like, mercury or thallium or some arsenic that's really going to poison you. So.
Not a question, but I recommend The Elements of Poison, a book by John Emsley.
Yep.
Goes through all the poisons, it's great fun.
Yeah, poisons are fun. There's a chapter about poisons in the book, in my book too. So.
With the elements that have a lot of history, like gold, silver, how did you determine what stories that you wanted to tell about those elements?
Yeah, there were some that had almost too many stories to tell. With mercury, I gave it its own kind of chapter. It's my favorite element. It was my book, so I could do that if I want. It kind of depended on the theme or how I thought they fit into the theme. So the silver story, for instance, again, there's a lot of different things you could do with that, but that ended up fitting well into the health theme because silver kills microbes very effectively. So I talked about how it kills microbes, why it kills microbes, kind of biochemically. And then there was this fantastic story about this Senate candidate in Montana. He was kind of a survivalist who started drinking water that was laced with silver ions because he thought that the antimicrobial properties would help him survive the apocalypse. He was very worried about Y2K, and he thought the grid was going to go down, and he was going to be the one who was going to survive. He did survive it. Unfortunately, a side effect of drinking silver is that it turns your skin blue. So he now has permanently blue skin. So I couldn't pass up a story like that. So basically, I was hunting around for a story that's memorable, something like that.
We have a question.
How did you investigate all of these stories and how did you find them?
Some of it, a few of them were stories I'd heard from professors or teachers or just sort of the oral history that you get passed down, among scientists. So I knew a few of them ahead of time. A lot of it, though, was just going to the library and picking up books on elements and just starting to look into things and just digging as much as I could. And if I found a mediocre story, trying to find something a little better. So there wasn't too much of a secret to it. It was just reading a lot and digging through a lot of either old papers or dusty books or whatever it took to find the stories for them.
You mentioned silver's antimicrobial properties.
Mm-hmm.
I know copper has similar properties, and recently, I'm not sure what groups, but I know several groups have been studying possibly using copper not only for medical purposes, but also in just places that generally where diseases tend to spread, using copper in place of other metals in various places that humans tend to contact. I don't know.
Yeah. So I talk a little bit in the book about how Legionnaire's disease, for instance, was an outbreak of a disease where basically there were microbes in an air conditioning duct. And because it was made of a certain material, they were kind of breeding and festering there. So oftentimes you see things lined in copper in air conditioning ducts where there's a lot of moisture building up. Hospitals probably use a lot of copper things too. So yeah, the copper and silver are right next to each other on the table, so they have similar properties in that sense too. So yeah, they were definitely looking at those kind of things.
Which element gave you the hardest time in terms of finding a good story?
The hardest time. There are some elements at the bottom of the table there, some of these rare earths down here that were a little difficult to find some stories on, just because they were not used in industry as much, or the stories of their discovery weren't as appealing. I once referred to them as the most useless elements on the table. I was on a radio show and I said something about how useless they were. And by the time I got home from the studio, I had 5 emails already from people scolding me about how very important all of these elements were. So I won't say they're useless, but they are not, the stories aren't as compelling in some cases. But there are still good ones out there.
We're going to have 2 more questions, so we have one here.
And I am going to be here signing books and things like that. So if you are feeling shy or you didn't get your question answered, I'll be around. So feel free to come talk to me.
How influenced were you by Tom Lehrer?
Tom Lehrer, so influenced in a way. I mean, I mentioned him in the book and things. So I love Tom Lehrer. He's great. And I do make sure to highlight him. He ran out, though, at element 103. I think that was the farthest he got in his periodic table song. But so I had a bit of an advantage. I had 15 more elements to work with.
You mentioned when there were elements that tended to have like a lot of stories that you picked one that like fit the themes of your chapters. Are there any like really good stories that just didn't quite make it into the book?
Someone asked me that earlier today, too. Not with this book. There definitely were with my other books. My genetics book, the red one there, and the neuroscience book. Those both had, that was a little harder to kind of cut the stories out. But the footnotes in the books, actually, they're not like dry academic footnotes. I can kind of take the fun parts that don't quite fit and I can kind of put them back there. So I was able to salvage at least some of them.
One more.
Okay.
Okay.
Yeah, I think it's the more important question tonight.
Okay.
Why do people in Ireland and UK call aluminum aluminium? Aluminium.
I think it's actually the rest of the world calls it aluminium, and the US is about the only people who don't. I mean, that's roughly how it is. And it actually goes back to that man I mentioned, Charles Hall. No one knows quite what happened, but as aluminum was exploding, he had called it in his patent applications aluminium, like everyone else does. And no one quite knows what happens. It might have been someone typing something for him, made a misprint, and left out that last U, or that last I. So instead of aluminium, it was aluminum. And he thought it sounded pretty classy. It sounded more like platinum, which is a very nice, classy metal. So he decided, for marketing reasons, to go with aluminum and not aluminium to make it sound a little better. And because he expanded so quickly across the US at that time, that's the name that stuck in the US. So it was a marketing decision.
Well, let's all give Sam Kean a big round of applause.